Greetings and welcome back to the lab. Time for an update and one extra little thing. Ultimately, this keyboard project, this DIY musical keyboard, is kind of in a holding pattern because I've had to order up a bunch of parts. I did finally figure out how to do an oscillator in such a way that I can start the process of making up that board, and I wanted to demonstrate that real quick. So here is what I laid out. It's a mess, yeah. I had to do it with parts that I have on hand, thus the giant capacitor here and the random electrolytic capacitor here. And I also need the speaker, which I harvested, which I said I was going to harvest. So let's get that plugged in. And then we need some power. And I put a little red LED here to show me that this is powered on. I don't know if I'm going to put that in the final design because it might just be distracting. But there we go. Now this is going to be a little hard to hear. Let me see if I can turn it up. Or, well, not turn it up, increase the frequency. It is ticking right now. And I'll try to lift it up so I can get the speaker closer. So hopefully that comes through. And I lost it. Parts kind of falling off while I'm trying to do this. So, but that's kind of the update there. Let me, I'll put this away. Meanwhile, while I'm putting it away, I want to show you the schematic as it stands at the moment. I may make a few final tweaks to the schematic, but it's literally got ultimately the game plan here is that every key on the keyboard has its own oscillator. That's a lot of oscillators, I realize, and that's basically a voice for every single key, which you don't normally find. That said, all of those are going to be mixed together, so there are 100 ohm resistors. I think that's about right. I can adjust that later. I've ordered up all the parts I would need to build this. They are 556 timers. I said I probably wasn't going to do the 555. Originally the plan was to do it with an even simpler hex inverter, because I get 6 of those in one chip instead of the 2 that I get on the 556. But I just couldn't get that to work, and it may have come down to the parts that I happen to have on hand. So stuff has been ordered. More stuff may get ordered, and I'm hoping to get this schematic implemented as a circuit board and then have it manufactured and then actually build it and try it out. So we're probably a week and a half, maybe 2 weeks away from that. So what I wanted to do was do something else productive, and I went out shopping today, just kind of browsing, and I found this spider web lights. Now, truth be told, I've already been into it because I wanted to test it out and make sure that the batteries I have were going to actually work. But the question here is this hackable? So if I open it up, what we end up getting here is all of this stuff. Let me put the box aside, with the battery pack. And yes, despite all the warnings, I have mixed batteries. But ultimately what I'm thinking is, can I hack what's in here? Now, there's a little bit more to this than you might think. You might think that you just turn this on and you get a spider web of lights. It says there's 60 LEDs and it comes with the spider to go in the middle of the web. Oh, it's already attached. Okay, well, that takes care of that. But ultimately, I've been thinking about, let me move this up a little bit. I've got these giant flat packs. I believe this is a 5 amp hour battery. Something like that. It came out of a laptop battery pack because that battery pack wasn't working, and I think the problem ultimately with that battery pack was that there were two cells. Let me grab the other one. There were two cells, but I think they were out of balance, and it didn't have proper balancing circuitry built into the battery pack, so it was unable to recover from the out of balance. It turns out they both take a charge. I got this one up to 4.05 volts. It started at 1.609 when I took it out of the battery pack. I managed to charge it up safely. This one made it to 4.12. It had 1.499. So if I could hook one of these up to this, then it might last a lot longer than a few AA cells. So let's take a quick look, and I'm going to warn you ahead of time, there's going to be flashing lights here because that's the whole point of this particular toy, if you will. So this actually has a button on it that's not just an on-off. I don't know how well that's going to come through. Get my shadow out of the way. Maybe you can see that there's a whole list of different modes here. So I actually ran through it until I figured out where off was. So now we'll start off from off. We'll go to number 1. It's supposed to be a combination. And once this one finishes, it'll switch to something else. And you get the idea. It's a combination of all the other modes. Mode 2 says in wave. I suppose that's kind of waving on and off a little bit. I don't know what that's really supposed to mean. I was expecting it to like move from some of these LEDs to others. There's another one that says sequential. Sequential could mean anything, really. Again, I thought this was going to be like chasing LEDs. Not really. The next one says slow glow. That one, give it a minute. Come on, there we go. It just slowly turns on, and then it'll fade out and do the same thing again. Chasing / flash. I think it's more flash than chasing. Now I should probably hang these up as a net and see what it actually looks like. But before I get to that, let's see what else we've got. Number 6 is slow fade. Yeah, that's a slow fade. Number 7 says twinkle / flash. The other one said / flash. That might be more effective for a Halloween kind of thing. And the last one, well, number 8 says steady on. That just leaves them on. And number 9 is off. So now the question is, if I pull the batteries out of this thing, how easy or hard is it to take apart? And can I reuse the circuitry, or do I just tap into this battery box? I probably don't even need to pull these batteries, because I can see that there's a little panel right here. I will bet you before I reveal it completely that there's, and I promise I didn't already look at this, there's probably just a blob chip on there. Oh, I'm wrong. Looks like we've got a little microcontroller. Chance for me to pull out my new pointer. So we've got what looks like a microcontroller and probably a resistor for controlling the current draw and other things. I will leave the kind of reverse engineering and stuff to Big Clive. Ultimately, though, it looks like I've got a battery contact here, a battery contact here, something like that. So I might be able to pull this out. I might be able to figure out a way to attach the big battery to this. Should be the same sort of voltage, and we'll see if we can get it to work. So that's the experiment. I haven't actually done it yet, but I wanted to get something that I could give you guys for a Thursday morning upload. I'm trying to stay on schedule despite delays and various things. So there's the hack. Yeah, I think it can be hacked, and I think I'll take a shot at that, and that may be the next video. Thank you so much for sticking around. Take care.